Right, welcome matriculants. This is now example number 2 of graph interpretation. Okay, right, so in this example we have that sketched below is f of x is equals to a times x minus 2 squared minus 9, right? Okay, so we see from the sketch and also from the equation, right, that that function is a hyperbola, right? And specifically we're given this in vertex form, right, which means that we know that the coordinate at the turning point, right, is going to be 2 minus 9. Okay, that's actually also indicated on the sketch over there. Okay, and then we have g of x is equals to 3 over x minus 5, right? So this is basically a hyperbola, right? And this is the mother function, right? It's been stretched by a factor of 3 and then moved downwards 5 units. Okay. So if it's been moved downwards by 5 units, okay, it also means that this hyperbola has a horizontal asymptote through, right, the line, through y is equals to minus 5, okay? Right, so now the question is determine the value or the values of x, right, for which f of x times g of x is going to be greater than 0, right? So that brings us back to our conditions, right? Similar to what we just solved, right? We are looking at this situation yet again, right? Okay. Right. So let's look more at this sketch. Right. Let's fill in a few things on the sketch, right? So we are given the coordinates here at A, right, which is an x-intercept. We're also given the coordinate at a turning point, and then we have another x-intercept here at B, right, but we don't know the coordinates there, but it's not that difficult to figure out, okay? Because we know that the x value here at the turning point is basically an axis of symmetry, right, for the parabola, right, then we know that the distance from here to there is going to be the same as the distance from the turning point to this next x-intercept. Okay, so what is the distance from A to C? Well, it's going to be 2 minus 1, right, which is going to be a distance of 3. Okay, so then 2 plus 3 more units will end you up at 5. Okay, so that is the coordinate over there, right? Now, I think we should be concerned about where this function cuts, right, the y-axis, okay? Right, so for that, we're going to need the equation, right? And the equation has some unknown a that we need to figure out, okay? All right, so let's try to do that. Okay, so in order for us to calculate a, it's useful to substitute a coordinate where the y value is 0, right? Let's rather substitute the coordinate that was given to us, right? So we're going to say solution, okay? And what we're doing here is we want the a value, right? So for a value, okay, we're going to sub the point a, which is minus 1, 0, okay? That's an x value, that's a y value, okay? So we're going to have, therefore, 0 is equals to a times a y value of minus 1, okay? And then we still have that minus 2, and all of this is squared, minus 9, okay? So we can take this minus 9, to the other side to give us 9 is equals to a times, in the brackets we've got minus 1 minus 3, which is minus 1 minus 2 which is minus 3, and all of that is squared, okay? Right, so then we're going to have 9 is equals to, well, minus 3 squared is also 9a, okay? So then therefore dividing both sides by 9, we get that a is equals to 1. Okay, Right, so then substituting back, we're going to then say, therefore, what is this function? It's G. I labeled it wrong. So it's fine, it's not a train smash. We can just swap these two things around. Call that G and call this F. Okay, because now I've gone and labeled them incorrectly. Right, so if you can see over here, I've labeled the hyperbola to be F. Right, so I've just basically corrected that over there. Right, so now we're going to say, going back over here, right, that therefore g of x is equals to a, which is 1. We don't really care about that anymore. X minus 2 all squared minus 9. Okay, then we can distribute this out, right, which is going to give us x, right, minus 4x plus 4. Okay, we still have that minus 9 over there. Right, and pardon me, I am missing a square over there. Right, so silly. Okay, so then if we collect like terms, right, which is basically this minus 9 and this plus 4, right, we're going to have x squared minus 4x minus 5. Okay, right. Okay, so why did I actually want to find the equation of g of x in the standard form? Well, because I know that this minus 5 is the y-intercept. Okay, right, so going back to the sketch, we now know that this point, right, is the point minus 5. Okay, right, so what else did we say about minus 5? Well, we said that minus 5 is the horizontal asymptote for the graph sorry guys, right, so for the graph f. Okay, right, so which means that through this line or through this point, okay, we're actually going to have a horizontal asymptote. Okay, and this horizontal asymptote is speaking to the hyperbola but doing absolutely nothing to the parabola. Okay. Right, so we've filled in quite a lot in our diagram now. Right, so let's try to see if are we capable of answering this question. Okay. Determine the value or the values of x, right, for which these two graphs, right, will be greater than 0. Okay. So let's go for the first condition yet again, right? We know that these two graphs being above the x-axis, right, that will satisfy that condition, right? So we're going to look at the graphs. We're going to grab a ruler, okay, and we're going to slide the ruler from left to right, okay, and we are now currently looking for both of these graphs being above the x-axis. Okay, right, so currently we're just looking at h, and h is below, and g, even though you can't see it, you should know it is above, right? Okay, they're still on opposite sides. Okay, when we get to this x-intercept, right, g is now going below. Okay, notice that f is still below. Okay, okay, both still below, they both still below, g is still below, right? Okay, now let's go back to this point, right? So this line, right, the y-axis, okay, or the line x is equals to 0, okay, and that is a vertical asymptote for the graph of f, right? So at this point, the hyperbola, as we all know, is now going to jump into its other quadrant, right? So it's now jumped into the first quadrant, right? So beyond this, right, notice that F, right, is now above, right, while G is still below. Okay, so there's F, it's now above the x-axis, right, and G is below. Okay, right, so let's keep moving. Look over there, right? So now we have an x-intercept, right, for F, right? So now F is now going to start being below, right? So it's below and G is also below, right? We are looking for both of them being above. So we keep moving. Keep moving. It's not going to happen, right? So it never happens, right? Okay, so let's do that again just to make sure, right? F is below, G is above. G starts being below, F is still below, right? Now F is above, but G is below. Okay, now F starts being below, and G is below, still below. Still. At this x-intercept, right, G now starts being above, but unfortunately F is still below. Okay, right, so this first condition is never met, right? But we have another, okay, sorry, just show you, right? So this first condition where both of them are above the x-axis at the same time, right, that is never met, okay? But we still have another condition, right? We still need to check for where both of them are below the x-axis, right? And we saw that happen quite a few times, right? So let's see back on the sketch, right? So it most definitely wasn't in this section, but as soon as we started coming over here, right, where G is below, right, and F is above, right, until we get to this x-intercept of F, right, where now F starts being below and G is still below the x-axis, right? So this is where we start. Okay, F is below, G is below, both of them are below, we are happy. Both of them are below, both of them are below. It's going to carry on happening until we get to this x-intercept of G. Okay, after that G leaves F behind, right? F is basically now continuously below the x-axis, right? So it leaves it behind. So this is where we stop. Okay, so what are we looking at? Well, we're looking at this interval over here. Okay, so if we can shade it in. Okay, so if we shade it in, we're basically looking for this region, right? This is the region of our interest. Okay, right. So the only really difficult thing about graph interpretation is that there's a lot of things happening, right? And there's a lot of things that can like take your focus, right? So basically, if I try to cover up the rest of this graph, okay, we are just looking at that region. Just that region, right? So can you see how both of the graphs are actually below the x-axis, right? So negative times negative is greater than 0, so that is the region we are interested in, okay? Or that's where our answer lies basically, right? So it's all about trying to focus your eyes to ignore all this other distraction, right? So everything else that's happening around here, right? All of that is just distraction. Okay, that's why we say use a ruler, right, to cover up the distractions and focus only on where the ruler is at that specific point in time as you are sliding along. Okay. All right. Okay, so as I keep looking at this sketch, I just realized we missed something, right? So this happens sometimes. So make sure you go back and you do this more than once, right? So notice that over here, right, we say that F is below the x-axis and G is above, right? But you get to this point where G, right, it's coming now. There we go. G is now going to start being below, right? And F is still below, okay? F is actually going to constantly be below the x-axis, right, for this quadrant, okay? So we're also looking at this region. Starting from there, right, so here comes G. G is below, F is below, right? And then up until here at the origin, okay, that's where it's going to stop, because at this point G is below, right, but F is above, right? If you can see F over there, okay, right, so it stops right over here. Okay, so I'm going to shade that region in as well. Okay, so if we pull our focus in again, right, we're basically looking at this region. Okay, can you see such a small little region? That's why it's, well, we missed it. Well, I missed it. Okay, such a small little region, but basically still satisfies our condition. Both of these graphs are below the x-axis. Okay, and then obviously we still have that other one that we identified. Okay, both of the graphs are below the x-axis. Okay, so see it, convince yourself, be confident about it. Okay, all right. So now let's think about, now that we've found these regions, how must we actually write out our answer, right? The important thing to note here is that we must not forget that this line is actually a vertical asymptote. Okay, so now because it's a vertical asymptote, we obviously cannot include it, right? So let's start with that fact, right? The fact that we can't include this x value of 0. Okay, let's think about whether or not can we include this x value of -1. Well, no, because what we're trying to do ultimately is to multiply the y values, right? So if we multiply the y values, one of the y values is 0, right? And 0 times whatever this is going to be 0, so we can't include that as well. Okay, so we're basically just looking for the solutions in between. Okay, now let's go over here. Well, over here, notice that we actually don't know what the x value is over there, right? But it's basically just the x-intercept of f, right? And that's something that we can calculate, right? So it's something we need to calculate actually, right? But for now, let's think about, are we including this x value or not? Well, the y value there is going to be 0, right? So then 0 times whatever this y value is going to be 0 as well. Okay, so we're not including this one. Okay, what about over here at an x value of 5? Same reasoning, the y value there is 0, right? So 0 times whatever this y value is going to be 0, so we're not including this as well. Okay, so we're just looking for the values in between. Okay, so to carry on from here, we want to find out what is the x-intercept of f, right? So we're going to state that. Okay, so we're going to say x-intercept of f, right? So the equation of f, remember, was f of x is equals to x over, oh wow, f of x is equals to 3 over x minus 5. Okay, Forgive me, I am a bit exhausted. Okay, right, so we're going to add over here, let f of x equals 0. Okay, all right, so we're going to have 0, right, is equals to 3 over x minus 5. Add 5 to both sides. We're going to have 5 is equals to 3 over x, right? We want to solve for this x, so let's multiply both sides by x to give us 5x is equals to 3, right? Because it's going to cancel out over here. Now again, last step to solve for x, therefore x is equals to 3 over 5. Okay, now you can check on your calculator what is 3 over 5, just to give you a sense of where that is. Okay, so it's 0.6, right? So let's look at the sketch and see, all right, 0.6 makes relatively some sense, right? If you look at its position from the origin, right? Even, but this is not to scale, right? So this, if you eyeball it, it seems like it should be the same distance as the other side, but note, remember that our sketches are sketches, right? So they're never to scale. We just need to accept the fact that from calculation, that is an x value, right, of 3 over 5. Okay. Right, so now to actually finalize and actually answer the question, we can now say, therefore, right, f of x times g of x is greater than 0, right, when x, and I feel it's always easier to write this in interval notation, right, x is an element of, right, starting off with this first interval. Okay, we're knowing that we're starting at this x value of -1, but we're not including it, so it's an open bracket, right, so -1, okay, up until we get to this x value of 0 over there. It's also not included, so open bracket. Okay, we've got two sets of solutions, so we need to then include that and say union. Okay, and we're now starting at this x value of 3 over 5. Okay, and then we're going all the way up to an x value of 5. And you're done. Okay, so that was example number 2.